This conference will now be recorded.
Okay, let's get started. So today's topic is not sure how many people are familiar with this particular terminology, but we are going to look at something called as Docker or Dockers. Let's call this one. So did anyone come across this term called Docker, Dockers? Anyone did you hear this term anywhere?
Yes, Abhishek. Docker containers, contain something like that.
Mhm. Docker containers, okay, Dockers, okay. So what do we mean by this, or what exactly is a container, or what exactly is this?
Might be related to storage account. I'm not sure about it.
It might be related to storage accounts, okay. Anyone else? Can anyone tell me what exactly do you mean by this term called Dockers or Docker containers? Anyone guys need a little bit of inputs so that we can get started? Guys,
Yes.
I cannot move. Sorry, go ahead, please. Yes, anyone else? Anyone else? A little bit of input, please. Let's make the session a little interactive. Is anyone?
No idea about this topic, sir.
Okay.
Okay.
Anyone else who's got an idea? Anyone else? Anyone? Guys, the class cannot be monotonous. It cannot just be like I am telling and you're just listening out there. It has to be both the ways. Please let me know. Okay, the host and to host and share applications. Okay, to host and share applications actually good. Yeah, that's a good input. Let's look at it. Before I move to Dockers, let's understand a little bit of about application development and how your applications are actually developed and so on and so forth. So let's see. So I am a developer working on my machine, and I get to write a code, right? So as a developer, I get to develop the code. And when I mean code, there are two things here. It's one the code, the other is the dependencies of the code. What do I mean by this again? So let's see. One is the code, the other being the dependencies of the code out here. When I mean the dependencies of the code, let's imagine this. Imagine that you're a developer who's trying to code an application, let's say called Ola, and this application called Ola, right? The code of this application, it has dependencies or it depends upon something called as .NET packages. Let's say like .NET 6 or .NET 7, whatever it is. It also depends upon something like Python. And for some reason, it also needs some generic softwares like Google Chrome. So all these softwares that your code needs in order to work properly are known as a dependency. So putting it in a very, very simple way, all these are dependencies right now. So As a developer, what I do is that I write my code and I tell what are all the dependencies that my code depends upon inside my, let's say, the settings file out here. And during the restoration process, when I restore this code during the restoration process, the dependencies get downloaded from the internet. And we use a package manager like NuGet in the form of, let's say, or for .NET applications. We make these dependencies download and available for the running code. So we are just making these particular dependencies downloaded. So we are just downloading those particular dependencies, and the code basically depends on all these softwares like NuGet or sorry, like let's say the .NET and all these things. So whenever I say it's a code, there are two things. One being the code, the other being the dependency out here. And I am a developer. I started developing all these things, and I've also, let's say, referred to all my dependencies. Everything is there with me. I need a platform to run this code on. Platform out here. So when I say platform, guys, can you give me an example of the platform on which you can run a code on? Any platform?
Web apps.
No, VS Code is a place where you develop the code. It's not a platform where you run the
Web,
code on.
web applications.
Web application. Yes, web apps. Or any other examples? Any rudimentary example? Virtual machine, can I say? Can I say
Yes,
a
virtual
virtual
machine.
machine? Yes, of course,
Yes.
a virtual machine. Because yes. So what I can do is that as a DevOps engineer, probably I'll give you a virtual machine. Let me put it here. I'll give you a virtual machine as a developer, and I'm telling that okay, fine. You know what? Give me a code and dependencies, and I will install something called as IIS on top of it. And once the IIS is installed, I'll then go ahead and host my code here. When I say code again, it's code plus dependencies out here. I'll host my code for, let's say, an application called Ola. And when I'm saying Ola, this is internally code plus dependencies. These are the two things basically I'm hosting here, code and the dependencies for this particular application called Ola. So code plus the dependency out here as such. So it's working good, fine, meaning as a end user, whenever I go to www.someola.com, the request from my browser is going to your application. The application is going to the IIS box inside, and that has all the code, has all the processing power. It goes ahead and gives you back the particular application, and that application is sent back to you again once again. So you are able to, let's say, see a booking site where you can go ahead and, let's say, book your cabs and so on and so forth. Now, what I can do is that using the same virtual machine platform, right? I can host not one but multiple applications. That's the idea, because I want to cut down my cost. I don't want to create multiple virtual machines out here. Let's say I have something called as irctc.com. I have something called uber.com. So I can host multiple applications on the same underlying host, which is a virtual machine out here. Will work, should work, shouldn't be a problem. When we do this, what we usually do is that we place a common dependency platform, meaning Ola has the same amount of dependencies, IRCTC has the same dependencies, Uber has the same set of dependencies. So all these three applications are dependent upon the same set of softwares. Let's say for Ola to run, I need a .NET 5.1. I need a Google Chrome version called Chrome 100. So some example out here. Same with IRCTC, same with Uber. Now let's say that one fine day, IRCTC is telling that okay, fine, in order to implement all the latest features, this shouldn't be 5.1, but it should be 7.0. So I change a dependency parameter so that IRCTC can literally or IRCTC can really run. But on the other hand, the other applications that are hosted on the same host, which is Ola and Uber, right? They might not support the same dependency platform, or they might not support the same dependency piece, or they might not support the same dependency upgrade. They might fail. So what I can do here in order to make sure that IRCTC actually runs properly is that I can create one more host, install all the softwares on this particular host, remove IRCTC here, place it on this particular host, and go ahead and let's say put a dependency here with the .NET, let's say 7, so that this can be a standalone application that is running on a virtual machine. But if I do this, I still need to pay for this particular machine. Earlier, I was just paying for this machine. I now have to pay for this machine also. If I have a good budget, that's okay with me. I go ahead and pay this out, but I'm not really worried about the cost. Yes, this is a factor that I will definitely worry, but more than cost, I'm looking at another factor called time. See, to actually migrate, sorry, to actually migrate that particular IRCTC application from this machine to the other, it's not that simple. It's just not I can lift my application and shift my application into a different host. It's not that simple. I have to first prepare the host. I have to make sure that this this host has the exact same configuration as the VM1. The VM2 should have or will have the exact configuration out here. Then I need to configure my IIS. Then I need to install all the softwares that are required, and then I need to let's say get my application here. Time taking process. Also, migrations are not easier. It's not easy. It's not just easy to go ahead and let's say migrate one application from one host to the other. Also, there is a factor called scaling. What I mean by scaling is that let's say the amount of load on this particular application called IRCTC is very high. I want to make sure that multiple instances of IRCTC are actually running, or multiple, or for high availability, multiple instances, meaning multiple hosts with IRCTC are running here. Let's say VM3, and then I put a load balancer on top of it and balance my application, which I can do. I should be able to do this, but again, whenever I create these machines, there is a cost that I need to pay. Again, the cost factor comes in, and also whenever I'm telling that I need a new instance of a machine, right? I again need to create the entire operating system. I again need to make sure that the entire operating system is remapped, softwares are installed, then the application is started. Again, not that easy. It will take a lot of time to let's say do this. The scaling of or the scaling up of an application is not that easy, which defeats my availability factor. It'll take a lot of time to actually scale all these applications out here as such. So a couple of issues here. One is that I'm not able to run a lot of applications on the same platform. The other is that the scaling issue. Third is that the issue with migration. That in a traditional application, which is hosted on let's say a virtual machine, or even as a matter of fact a web app. See, a web app is sorry. See, a web app is nothing but a virtual machine that is running in the background. It's simple. It's a host. It's a virtual machine host that is exposed in the form of a web application out here. That's it. Nothing but that. Nothing but let's say a simple web application out here. I mean, a simple virtual machine, but exposed in the form of a web app out here as such. So again, it's the same issue. That's where containerization as a concept comes into picture. Containerization. The idea of containerization is itself this. It's that as a developer, now I'm telling, okay, fine. I'm asking my developer to give me, as a DevOps engineer, the code plus dependencies. I'm telling, tell me what are your code, what are your dependencies. Give me the same thing. And what I'll do is that I will write a file for this. I, as a I'll write a file for this. We'll talk about what kind of a file this is again. And using this particular file, I will convert your entire code and dependencies into something known as an image, into something called as an image out here. So image here is nothing but it's a static layer of the underlying code and the dependencies. That's it. So code and dependencies is tagged inside something known as an image, uh, small in size. Let's say about 3 GB or something like this. And now I'm telling that, okay, fine, all your code and the dependencies are stacked together, meaning then if you look into an image, right, the image will just have things like, okay, fine, this is the code, this is the dependency that the code really runs on, and so on and so forth. So now I'm telling all my code and dependencies are packed together into an image. And if I run the image, if I run this particular image, this will give me something called as a container. So even before I'm talking about container, I'm talking about an image out here. This will give me a container. Now container is nothing but a running instance of the image. Meaning if you just run this particular image, it'll give you a container. And if you look inside the container, right, you'll just find all that code and dependencies. That's it. You'll just find a code. Yes, you'll just find the dependencies of the code. So then how does this, let's say, really work out? How does this, let's say, really go ahead and let's say work out here? So for this container to run, right, you again need a platform. This container just cannot be running in the air. It needs to have a particular platform. That's where I'll get my virtual machine back again. So I'll tell, okay, fine. I have one virtual machine and this container that you talk about, right? I'll say, okay, fine. I can run this container called IRCTC application on this particular virtual machine. At the same time, I can run another container called Uber. I can run another container called Ola, all parallelly with each other. And if I need one more instance of this container, I don't want to create another virtual machine. I can simply make one more instance of this particular container and load balance it out. That's a different story, of course. But again, since the container, right, has its own code and dependencies, if I change the dependency of container 1, container 2 or container 3, they are not impacted because each and every container is an isolated unit from each other. And in this isolation, you just go ahead and get these two things called as a code and dependencies. And this is itself called as containerization. This itself is called as containerization. So containerization is nothing but just packing the code and all the dependencies that your code really relies on and running it on a platform. Now, there's one issue though. When I run this on the platform, right, like a virtual machine, the virtual machine cannot understand the language of containers. It cannot really understand what the containers are really talking about because the operating system of the virtual machine, either being Windows or Linux or whatever it is, the OS cannot understand the language of the containers because it's all in high level language. It's all high level. It really cannot understand this out. So it needs something, or it needs someone, or it needs something here in between the VM and between the containers. It needs a software, and the software is called as a container toolset software. A container toolset. And when I mean a container toolset, it's nothing but a piece of software, that's it, which will help compile the entire language of this particular or whatever this particular container is talking. It will communicate to the OS, and that are running on top of the host. And without the host, or without, let's say, this particular tool set, your containers cannot run on top of a virtual machine, or your containers simply cannot run on any platform, whether it being an on-premise server or whether it being a web application or wherever it is. And this container toolset software, right? I mean, it has, let's say, multiple people have designed this. There are multiple players who have, let's say, created this container toolset software. So you have something called as RKT in the market, Rocket. You have something called Cryo. This is the other famous container toolset software that is available in the market. But the famous of everything is called as Docker. So Docker is nothing but a software. It's a container toolset class. It just goes ahead and, let's say, helps the VM understand the language of containers, and it helps the OS, let's say, communicate, and both, it acts like a to and fro communication out here as such. That's where Dockers come into picture. So let me bring in that particular software. Looks something like this: a dolphin with a lot of containers on top of it. So this is where Dockers come into picture out here as such. And on top of a Docker, so this is how we do it. We need a platform. It can be my virtual machine also. It can be my virtual machine also to test out things out. It can be my virtual machine also. I can have something like Dockers installed on my virtual machine. So if I say something, I have something called Docker desktop. I can have Docker installed on my virtual machine. Or in our case, let's try to do it on a virtual machine. So I need a VM. On top of the VM, I install something called Docker. On top of Docker, I start my journey with containers. So this is the idea going forward on how do you go ahead and, let's say, install containers or install Dockers and, let's say, start the containers and so on and so forth. And this was just the introduction. I'll go into the demo in a second. But before that, any questions that I can take with what exactly is Docker and what is containerization? This is very, very important to understand the classes going forward. So we will need to understand what exactly is a container, what does containerization really means to us. And once we understand these two terminologies, we can go ahead and move forward and understand how exactly all these things work together. So yes, any questions, guys? Anyone, any questions till here? Am I good to move forward? Any questions? Anyone, anything?
No doubts.
Okay, then let's move forward. So this is what I'll do in today's session. I need a host, right? So firstly, I need a host where I can run all these things. So what I'll do is that I'll create a virtual machine in Azure portal. Again, this is optional in nature. Virtual machine, I'm just showing you how to create this out and host your applications. You can also directly use your laptop as a host. You can use the laptop as your host out here. Shouldn't be an issue. I'll also tell you how do you do that at the end of the session. But for now, I'm doing a virtual machine out here as my host, and a virtual machine with an operating system called Linux. And the flavor of Linux that I'm using is Ubuntu. It's 20.04. This is the flavor of Linux. Again, when I say Linux, Linux has multiple flavor, guys, just like Windows. Windows has Windows 2016, 19, 22, Windows 2012 server, Windows 10, Windows 11. In the same way, there are multiple operating systems that Linux offers, like Ubuntu, Fedora, Cent. You have Debian, a lot of things out here that Linux really offers out here. And I'm selecting Ubuntu because one of the most common, let's say, Linux platforms that I can go ahead and let's say create. And after I create the host on the Azure portal, I'll use some commands to install a software called Docker. So let's do that. Let's do these first steps and then come back. So I'm going to the Azure portal, and if I look at my virtual machines today, I don't have any. I'll create a VM, and if I just scroll down, I'll create something called as Docker RG, a resource group out here. I'll just scroll down. I'll say this is a Docker VM, and I'll just go ahead and select the region called ECS2. Availability options, no redundancy, infrastructure required, security type is okay. Earlier we used to select Windows Server 2019. Right now I'm selecting a server called Ubuntu Server 20.04 LTS long term support generation 2, and I'm telling this 64-bit architecture. I'll just scroll down, and this is the size of the machine. Alternatively, whatever size that is offered in your free trial subscription, you can take this. I don't have any issues with that. And then I have SSH keys or passwords. I'll say it as a password. I'll go with a simple authentication called password out here. I'll just give the username and password just like I did with a Windows virtual machine. And I'll allow the selected ports HTTP, HTTPS, and something called SSH. There is no RDP port here. There is nothing called as an RDP port out here. You will not get RDP for a Linux operating system. RDP is only a concept for Windows. For Linux, you have something called SSH. You will need something known as an SSH out here for Linux. We'll see how do you connect to a Linux operating system also. So let me go ahead and say disks again. I'll just go with the defaults out here. Networking also, I'll go with the defaults. Monitoring, I'll just disable the monitoring out here. Advanced and review and create this out. So I'm creating a VM with that particular image called Ubuntu Server 20.04 LTS long-term support. And the others, I just opened up a couple of ports like HTTP, HTTPS, and SSH. And the other options, I just took all the defaults and I'm creating this VM. And this is a VM running on a Linux operating system. And in order for you to connect to a Linux operating system, right, you need something called as an SSH client, because Linux supports the SSH software, and operating systems like Windows, which I'm using in my laptop, cannot directly connect to this particular, let's say, VM that is there on the Azure. You will need something known as an SSH client, nothing but an SSH software out here. Again, you have a lot of SSH software that are available out there in the market. One thing that I would personally suggest is something like PUTTY. There is a software called Putty. It's an open source terminal, or it's an open source software to go ahead and connect to a virtual machine. So I'll say download this for free. I'll say download Putty. And as and when I do this, I have three different types of installers: x64, 64-bit x86 architecture, ARM architecture, and also 32-bit architecture out here. Now, this piece of software worked for me because I am on a 64-bit ARM architecture. You can either go for this or this, depending upon, let's say, the architecture that you're on. You can try one of them. If it doesn't install, just tell that you know what, this is not supported. You can try the other one. Or if you are on 32-bit operating system, you can go ahead and download this out. And once you download this out, a very simple installation procedure. Just say next and do the installation. And just after the installation is done, just type in putty and you'll have this particular application that is there. So it looks something like this. It'll say putty configuration, it'll say host name, it'll say all these things out here. So this will give you uh, a portal, or this is a tool to go ahead and let's say connect to a virtual machine. with Linux operating system on top of it. So I have a VM, and this VM should have a public IP address. So I'll copy this public IP address. It's running on a Linux operating system out here. I'll go back. I'll paste this IP address, and I'll say open. And as and when I say open, it'll say, okay, fine, do you want to accept? I'll say yes. And I'll increase the screen slightly so that everyone can see this out. Let's say change settings, appearance. I'll go ahead and change the font. Okay, so it's telling login as. I'll say I'll log in as a test user. I'll say enter. It's asking me for the password here. I'll just go ahead and give the password and say enter. So again, when I give the password, right, if you observe, there is nothing that got typed. So it'll just go ahead and let's say it won't show you what you're typing. You just have to go ahead and let's say enter the password. And I am inside the operating system right now. I'm inside my virtual machine right now. So now it's telling test user at the rate Docker VM. So you are connected as a test user to a Docker VM out here. And this is the operating system. This entirely. I mean, it doesn't have a GUI. This doesn't have a graphical user interface. It's just a simple machine out here that you get out here as such. It doesn't really give you a graphical user interface and all those things out here as such. Now, any questions still here? Anyone, any questions that I can take before we move forward? Anyone, any questions on how did we create this VM and how did we connect to this particular VM out here? Guys, any questions?
No, sir.
Okay, good, please. Correct, correct. Like RDP for Windows, we use Putty to go into this particular virtual machine running on a Linux. Your voice is too low, Pavni. I'm not able to get your question. Can you come again, please? Yeah, we can do that in Linux also. Yeah, we do the same thing in Linux also. We have multiple command lines to do that. Linux doesn't give you a GUI. It doesn't have a graphical user interface. It's open source pretty in nature. You have command line to do that. You can run multiple commands now to install the software. Yes, and that's where I will come down to the software installation part. So let me go there and just a second. Yes, that's where I'm coming down to the software installation part. And one piece of software that I'll install right now is a Docker software. So installing the Docker software is the second thing. How do I install it again? I'll just go to docs.docker.com. This is the documentation, the official documentation for Dockers. And here it has something called download and install. And if I just scroll down, it is telling there's Docker desktop for let's say Mac, Docker desktop for Windows. Then you have Docker desktop for Linux. So I'll go to Docker desktop for Linux. I'll just scroll down. It's telling it should have a 64-bit operating system and etc. And it's telling the available Linux platforms are Ubuntu, Debian, and Fedora. These three things. It doesn't probably have something like CentOS or something like that. So I'm running on an Ubuntu platform. I'll say I want Docker for Ubuntu. I'll just scroll down and it's telling there are a couple of prerequisites. So you have to install some terminals and all these things. How that's good enough. If I just scroll down, it's telling install Docker desktop. Recommended approach to install. Step one is to first go ahead and set up something called as a Docker package repository. So I'll click on this. As and when I click on this, right, it's saying, okay, fine, set up a repository. So firstly, it's telling you have to run this command called sudo apt-get space update to update all the existing packages that are there on your machine. So when you create a machine, right, you get some existing packages as a part of that particular machine. So it's telling, please go ahead, update this out. So again, I'm copying here. I'll do a copy. you cannot do a control V here, guys. Linux doesn't support, or this particular version of Ubuntu doesn't support, let's say, control V's out here. So you just have to do a right click. As and when you do a right click, right, it'll just paste it out. And as and when I do that, it's going ahead and running an update. And all the packages that are inbuilt in my system are getting updated. So it's just going ahead and updating all the packages. And after that, it's saying, okay, fine, I'm done with the update. Tell me what to do next. Again, from the documentation, there is something called installation. And whenever you want to install something, you have to write this command telling sudo as a root user or as an administrator user for administration privileges. I'll say apt-get install, and I'm installing something called CS certificates, installing something called curl. All these are important to go ahead and do some HTTP, connection and all that stuff. So I'll just go ahead. I'll copy this command again. I am not mugging up these commands, not at all required. I'm just copying this up. Again, doing a right click here and say enter. It says, okay, fine. Here it's saying, do you want to continue? I'll say yes. So it's going ahead and installing something like CS certificate, client certificates, and all these things out in order for my machine to get ready. And once this is done, it's telling make directory, and it's making a directory called etc apt keyrings or something like this. And then it's using something called as a curl, and it's downloading a file, and it's going ahead and telling, okay, fine, please go ahead and put this file inside this. So I'll copy this out. I'll place this and say enter. That's it. So I'm just doing a copy paste and then the enter. I'll just scroll down, and now I need to set up something known as Docker repository, where Docker needs to, let's say, do a lot of downloads, and Docker needs to have a good amount of control. So I'll copy this out here. I'll say enter. I set up the Docker repository, and finally I'll update my packages once again. So I'm updating all the packages once again, and finally in the very last, I'll go ahead and say install Docker CE Community Edition. I'll copy this out. I'll paste this here. I'll say enter. Saying, do you want to continue the operation? I'll say yes. I'm finally going ahead and setting up the Docker out here as such. So I'm installing the entire Docker package, and all I did is nothing. I just went here, took these commands, and I just went into my virtual machine, installed all these things out. Now all these commands are also there inside our projects also. So if you want to take a reference, you can go ahead and see these commands out here. Let's see, Docker install Docker VM. Yes. So I just copied all those commands and placed it here so that it will be easy for you to, let's say, go ahead with this. But I would I would suggest going to the Docker documentation, because the documentation keeps getting updated very frequently. So you can go to docs.docker.com and do the same thing what you're doing from this link. So both are the same, either from Docker documentation or from this particular link. Anything is okay. You can go ahead and install the entire thing out here. And if you want to go ahead and also install Docker on a Windows operating system, I've also given the steps out here. So there is something called, meaning in my system there's Docker that is installed directly. It's a big software, so that's the reason I was going ahead and doing it in a VM on a virtual machine out here. But if you want to install it on your own laptops, you can, most probably you can do this from this particular link. So I'll also give this on how to install Docker on a Windows OS. Installing Docker on a Windows operating system out here as such. So anything, I'm good with that. And now the Docker is installed. And if I want to see whether the Docker is installed or not, run a command called sudo, which is, as a admin user, I'm telling Docker space version. Installing, this is the version of Docker that is installed. It is running on a Linux operating system and all these things out here as such. So you should be able to see this particular command, or you should be able to see, let's say, this particular thing telling that, okay, fine, the Docker is installed out here as such. So that's the installation of Dockers. This is step two. So step one was, let's say, creation of the virtual machine, connecting to the virtual machine using a software called Putty, an SSH client. And after that, I have run some commands to go ahead and install a software called Docker out here on this particular VM. And once done, I'll start with, let's say, the regular operations out here as such. Yes, any questions still here? Anyone, any questions still here that I can take? Anyone, any questions I can take till here on how do you install the Docker software? What do you do with the Docker software and all these things? Any questions, guys, or am I good to move forward? Guys, any
No questions.
questions? Okay. Guys, if I'm asking something, please do respond back to it. If it's a yes or no, I want you all to at least type it in the chat or tell me out here as such, because I cannot be just talking to myself out here. Okay, so let's move forward. So the next thing that I want to do right now is I want to use my Dockers. So this is what I do. This is what I did. So I'm going to containerization right now, and what I want right now is an image. So I said that one of my developers can go ahead code this out. I can write a file. I can get an image. Let's imagine that you don't have a code. You want to, let's say, go ahead and download a simple image out here. Can you download that? Yes. Can you download that? You need to go into something called as hub.docker.com. It's called a Docker Hub repository when you find images. So I'll say explore, and here I have multiple images out here. There are multiple images that different companies, that the developers of different companies, right? They went ahead, wrote all these images, or wrote all those files and converted them into an image. And one such image is called Nginx. It's a web server like IIS on Windows. Nginx is, let's say, Nginx or Tomcat. All these things are for, let's say, something like a Linux operating system out here. And here it tells me a command that, okay, fine, if you want to pull the image, run this command called docker pull space docker space pull space nginx. I'll copy this out. I'll come here, and before I run this out again, if I directly run this out, right, it will give me that you do not have a permission and all that stuff. So that's the reason I need to run as an administrator user. So I'll say sudo and space. Okay, I'll say sudo. The command did not get copied properly. I'll say sudo docker pull nginx. Nginx. The spelling should be correct. Nginx. And say enter. So it's telling, okay, fine. I'm pulling the latest version of Nginx. It's pulling all these images, telling download is complete. It's telling downloaded the newer version of the say Nginx latest, and the image is present. And if I have to look at the image, I'll say sudo docker images or sudo docker image space ls. Anything is okay. Any command is okay. So if I do a sudo docker images, it's telling, you know what, you have downloaded an Nginx image, which is about 142 MB. This is the image ID. This image was created about 2 weeks ago. It's telling me that, okay, fine, someone from the development team of this company called Nginx, they created this particular image. Good enough. Now I want to run this image. And if I want to run this image, right, meaning I want to convert this image into a container. And firstly, let me see if there are any containers that are already there in the background. So I'll say sudo docker container ls container list. And if you see, I do not have any container. There's no container ready. There's nothing out here. So what I'll do is I'll say sudo docker run space the name of the image nginx, and I'll say enter. As and when I do this, right, there are a huge set of logs it gives me, telling that, okay, fine, it's not an empty, and it's going ahead taking that image. It's telling, okay, fine, it started this particular process. So what it did right now is that as and when I said that, okay, fine, please run a container, it now created one simple container called nginx out here using that particular image called the nginx that I just downloaded from the Docker Hub. And now a container is running on my underlying host on top of that particular Docker software that I installed. So this container has a process ID of, let's say, something like 30 or 29, something like this. So it is a process. A container is nothing but a process on top of a virtual machine. But the issue here is that the container is like running in this way. So if you look at this, right, the container is attached to my terminal. The container is running in an attached mode. This is called container running in an attached mode out here. So the container now is running in an attached mode. So what happens is that if I want to run any commands, right, if I want to do something on this particular VM, in order to come out of it, I will say Control C. As and when I do a Control C, right, it will firstly kill the container and the container exits out. So whenever you kill a container, right, the container is destroyed. Container is nothing but a process. So the container is deleted, the container is destroyed. So there is no container that is running right now. So if I say sudo docker container ls, I don't have any containers. I don't have any containers that are running. But if I want to see all the containers that are exited also, I'll say sudo docker containers ls space hyphen a all. So now I have a container that ran, created 2 minutes ago, exited about 37 seconds ago. That's where I killed the container with the name something like this. Some Johnson, infallible Johnson, something like this. I did not give a name to the container. So what I want to do is that I want to run this container, but I want to run this container in the background. So what I'll do is that again say sudo docker run space hyphen hyphen name, and I'll give a name to my container. I'll say this is my first container. I'll say hyphen D, run in a detached mode, and the image source space nginx nginx. What happens is that your container doesn't get attached to the terminal. It is running in the background. And if I now say sudo docker containers or sudo docker container ls, I have a container with this particular ID that is running in the background, telling that okay fine, this is my first container and so on and so forth. It's running in the background out here, telling that yes, I am running in the background, it's up, it's all running and all that stuff. So the container is actually running with some amount of, let's say, or with a simple image called or nginx out here. It is nothing but a web server. The container is running, but I as a user, right, I won't be able to go ahead and let's say look at the container because or look at the content inside the container because if I run a command called sudo docker inspect space the ID of the container. So this is the ID. So I'm just copying it and doing a right click here. If I do the inspect, I get an entire JSON body telling what is the ID of the container, the full ID of the container. Then it's telling what is the path where it is running, what is the image source out here. So if you just scroll down, it's going to tell you what is the image source, what is the network and all that stuff. And if you just scroll down out here, the container has an internal IP address. The container has an internal IP that is assigned to this one. And it is telling that, okay, fine, the container is accessible via this particular internal IP, meaning the content that is running inside the container or the code or the application that is running inside the container is accessible over this particular internal IP, and this internal IP is only available within the virtual machine, meaning you have to be inside the virtual machine in order to see the content. But if I am a user and let's say I am from the outside world and I want to use the internet in order to let's say look at the content that is running inside the container, I have to expose my container. I have to expose my container to the internet using the VM because this is the only IP that I have. So using this particular virtual machine, I will have to expose my container to let's say the outside world. That's where port exposure comes into picture, publishing a port. So what I'll do is that I will run the container once again. So I will have a container here, but before I run this, I will give a simple command called -p 80:80. We'll talk about what this is and say enter. It's telling the name of the container is already there, so you have to remove or you have to create a new container. So let me do one thing. I create a new container here. The old container did not, let's say, so I'll say this is my container. -p, I'll say enter. Now let's see, I have two different containers. One container is not accessible, the other container is exposed. I'm using a command called -p. I said 80:80, and let's see. Look at all the containers that are running in the background. There is this my container, there is this my first container. My first container doesn't have any exposure, it's just within the virtual machine. Whereas the second container, I've exposed it over a port called 80 of the virtual machine. So what this means is that if I take the virtual machine IP, go to my browser and say enter, it's now telling welcome to Nginx. So I as a user, what I'm doing is that I am hitting the public IP of that particular virtual machine. And when I did a command called 8080, right, the virtual machine is telling that whenever I get a traffic at a port called 80, internet HTTP traffic, I will divert this to a port called 80 of the container. This is called port mapping. So I'm telling, okay, fine, whenever you get a traffic at this particular port called 80 out here, divert it internally to a different port called 80. This is how I'm diverting it out, and that's the reason I'm able to talk to that particular container over the internet. So if you see this, now this is the container. Now if I stop the container, now this is the container ID and this is my container out here. If I stop this, if I try to stop this, I can say sudo docker simple command stop. It's the ID of the container. So setting the container is stopped. Now if I say sudo docker container ls, I only have my first container that is running, no exposure at all. If I come here, refresh this page, since the container is stopped, you won't be able to see any content. It's not running at all. It's not running at all. You won't be able to see any content out here. If I start this back again to start, simple sudo instead of docker stop, you say start and the ID of the container and say enter. Container started. Refresh the screen out. Then you again have this particular Nginx page. In place of this simple HTML, right? You can have your own HTML. You can have your own custom pages. You can have your own .NET pages. You can have multiple things out here as such. So this is how we go ahead and create the containers, and this is how I expose the container. This is just one simple container. We also, going forward, we'll also see if you have multiple containers, what can you do? How can you, let's say, run them, and so on and so forth out here as such. And again, I have all these commands that is written here. There is something called docker commands. I said, how do you pull? How do you, let's say, pull a different image? How do you remove an image? How do you, let's say, stop a container? How do you see what are the containers? How do you run all these things out here as such? Yes, any questions still here, guys? Anyone, any questions still here? Any questions that I can take till here? Okay, guys, thank you. So that's it from me. Thank you, guys, and have a good day ahead.